So this question is from exercise 4E, question 11 from the Edexcel book. It says, an inverted conical funnel is full of salt. The salt is allowed to leave by a small hole in the vertex. It leaves at a constant rate of 6 cubic centimeters per second. Given that the angle of the cone between the slanting edge and the vertical is 30 degrees, show that the volume of the salt is 1/9 pi h cubed, where h is the height of the salt at time t seconds. Show that the rate of change of the height of the salt in the funnel is inversely proportional to h squared. And write down the differential equation relating h and t. So there's a lot of information here in this question. We're going to start by doing a sketch of the shape that we have. So they've told us that it's a conical funnel, which is full of salt, and it's allowed to leave a small hole in the vertex at a constant rate. So it leaves at a constant rate of 6 cubic centimeters per second. So I'm just going to write that down. So I know, because it's a rate of change and it has centimeters cubed, that's my volume. So rate of change, and I know it's with respect to time because I've got seconds here. Okay, so per second. So that's going to be 6. And we have to be careful because here it says it leaves at 6 cubic centimeters per second. So it's -6. Okay, and if I sketch the funnel, this is what we have. It says that it has a height of h, and also that the angle between the slanting edge, which is this one here, and the vertical is 30 degrees. Okay, this at the top is going to be our radius. Okay, so whenever we want to find the volume of a cone, we need to have the radius as well. Okay, so we have now used the angle of 30 degrees. That's the angle. And it says h is the height, time is t. Okay, the other information that we have is that the volume is that. So I'm just going to write that down. So I know the volume is equal to 1/9, and this is what I need to show, 1/9 pi h cubed. Okay, so it says to show that that is true. So we're going to do this bit first. Okay, so volume, we have a cone here, which means we need to know the formula for the volume of a cone. And that's going to be 1/3 pi r squared times by the height. Okay, it's difficult to find, or impossible to find the value of r and h with the information that they've given us. And we can't find the volume with 2 unknowns. So I'm going to write this in a different form because we've got the angle here at 30 degrees. So using SOHCAHTOA, I've got the opposite and the adjacent. So that's going to be tan. So I've got tan of 30 is equal to opposite over adjacent. Okay. If we look back at what we need to show, here they've got the volume without r. Okay, they've only got it in terms of the height. So I need to get rid of r. I need to show what r is equal to. So I could say that r is equal to h. I'm just multiplying through by h, tan 30. And putting that into the calculator, r is going to be equal to h root 3 over 3. So this is what I'm going to use for r. Okay, so now I'm going to substitute it into this equation here. Okay, so we're going to have the volume equals 1/3 pi r squared. So r is now h root 3 over 3. I need to square all of that and then times it by h. Now it's just a case of simplifying. So that's equal to 1/3 pi. I'm going to square every term inside that bracket. So I've got h squared. Root 3 squared is 3, divided by 3 squared, which is 9. And all of that is times by h. So now I'm going to see if anything can cancel. I've got 3 divided by 3 is 1, and then my h squared and h will turn into h cubed. So I would be left with pi h cubed over 9, which is the same as what they wanted. They wrote it in the form 1/9 pi h cubed. Okay, so this part here we've done. We've shown that the volume of the salt is 1/9 pi h cubed. The next part says show that the rate of change of the height of the salt is inversely proportional to h squared, and write down the differential equation relating h and t. So I've got dv by dt. So I've got the rate of change of the volume with respect to time. And I need to find so in this question it says show that the rate of change of the height, so I need the rate of change of the height, so I need to find dh by dt. Okay, that's what I need to find. So I'm going to use the chain rule, because we've got dv by dt equals dv by dh by dt. Okay, so this is the bit that I need to find. I know what this one is, that's -6, and this one I can find using this formula down here. Okay, I just need to differentiate that. So I'm first going to differentiate v with respect to h. So I know that v is equal to 1/9 pi h cubed. We've got it in terms of h, so we can find dv by dh, and that's going to be equal to 1/9 pi. Okay, that's just a number. I'm going to bring down the 3, so multiply by 3, h squared. Okay, so simplifying that gives me 1/3 pi h squared. Now I'm going to substitute that in, and I'm also going to substitute in dv by dt, because we know what that is. So I've got dv by dt equals dv by dh, dh by dt. So dv by dt is -6, and that's equal to 1/3 pi h squared dh by dt. I need to find out what dh by dt is, so I'm going to rearrange it and divide through by all of this. So I've got -6 divided by pi h squared over 3, and that gives me dh by dt. Simplifying that, I can change the division into times and then flip the fraction over. So that's just your change and flip. That would give me -18 over pi h squared. Okay, that is my rate of change of the height with respect to time. Okay, so this is the answer that they are looking for. So we have shown this bit here. Write down the differential equation relating h and t. The last bit, it says show the rate of change of the height of the funnel is inversely proportional to h squared. If something is inversely proportional, we know that it's going to be 1 over h squared. Okay, which means that this one here, it is inversely proportional because we've got the h squared at the bottom of the fraction, okay, in the denominator. So we have answered every part of this question.